The fifth question. Three charges are at the corners of an equilateral triangle as shown in the figure. So it's exactly equilateral triangle. Calculate the electric field at a point midway between the two charges on the x-axis. So in the previous question, we are calculating the electric forces, am I right? That means electrostatic force. But in this question, we are going to find what should be the electric field. Clear? So that's very, very important. Electric field, we know the value, am I right? So the formula E, which is equal to KQ over R square. That is the rule, am I right? So read the question. We are going to find what should be the electrical field. Which place? In the midpoint, they mentioned here. So in this point, we are going to identify what should be the electric field between the two charges on the x-axis. Clear? So every time we have to apply, because let's see, this is our Q1, because they did not mention the value, which one is Q1, Q2. We can take as it is. So this one is Q1, this one is Q2, this one is Q3, and we know the rule for the electric field for the point charge, which is E is equal to K Q over R square, and this is magnitude, right? So better we can substitute this. We can use this equation for each charge, and then after that we can find the net charge, right? Net charge, net electric field. So electrical field for the first charge, and here they said the H value is given 0.433, and it is also easy. Even if they did not mention the value of this H, we can find by ourselves. But anyhow, I can show you that method. It's very easy. Okay, let's find what is the electrical field of the first charge at this point P. Let's take this is the point P. Okay, so in this point P, we are going to find what should be the electrical field by the first point charge Q1. Clear? So E1, which is equal to K magnitude of Q1 over R1 square, and this R1 square here is nothing but, so the distance from the Q1 to this point, here R1 is nothing but H they mentioned. Clear? So let's substitute the value. 9 multiplied by 10 power plus 9 multiplied by the magnitude of this charge is 3 multiplied by 10 power minus 9, because it is nano, over what's the value? 0.433 square. Clear? I directly use this value because here H is nothing but the distance between the charge Q1 and the point P. So now we have to find what is the value. So better I will calculate first. 9 10 power 9 multiplied by 3 10 power minus 9 over 0.433 square. I got the answer as 144. Exactly 144. What's the unit? Newton over Coulomb. Likewise, I have to find E2. So K magnitude of the second charge over the distance between charge 2 and point P. So what is the distance? Because as we already studied in the previous question, all sides are exactly the same. So what is the distance between these? Because this is half of the distance, am I right? So the total distance they mention as 0.5. So what is half? This is 0.25 and this one is 0.25, right? So the distance between the second charge and the point P is 0.25. So R2 square, we have to substitute the value. 9 multiplied by 10 power 9 multiplied by the second charge is 8 nanocoulomb. 8 multiplied by 10 power minus 9 over the distance between the charge 2 and the point P is 0.25. So 0.25 square. Let's see what's the answer. So 9 10 power 9 multiplied by 8 10 power minus 9 over 0.25 square. I got 1152 Newton per Coulomb. Clear? Okay. And then the similar manner we have to find what is the electrical field exerted by the third charge. So K magnitude of the third charge over R3 square. So 9 multiplied by 10 power plus 9 multiplied by third charge is a negative, but we are going to take only the magnitude. So 5 multiplied by 10 power minus 9 over, again the distance between the third charge and the point P is 0.25 square. Let's see what is the answer. 9 10 power 9 multiplied by 5 10 power minus 9 over 0.25 square, I got, what is this? 9, 10 power 9 multiplied by 5, 10 power minus 9 over 0.25 square. I got 720. What's the value? 720 Newton per coulomb. Clear? Okay. Now we are going to find what should be the direction. I think they need the electric field. Am I right? Am I right or not? So we have to find its direction. Did they mention? Because this question, we are going to find the electrical field, means it has the direction as well as the magnitude. So better we can calculate its magnitude and the direction. So for that you have to play with each charges. You have to use the test charge. So what will happen if you take the test charge? What is the test charge? Test charge is always positive. Am I right? So you have to take the test charge and you have to bring near to each charges. So test charge is positive. When you take the test charge from this point to this place, what will happen? So better I can erase all these. What will happen? Test charge, I am going to, for every cases, I am going to bring the test charge from this point to the first charge. So what will happen? Test charge is positive and this Q1 is also positive. What will happen? It will repel, right? Likewise, if you bring test charge from this point to the second charge, what will happen? It will repel, right? Likewise, if you bring the test charge from this point P to Q3, what will happen? It will attract. So that means the two arrows are in the right hand side and one arrow is in the downside. Am I right? That means this arrow is the electrical field of first charge and this arrow is the electrical field of second charge and this arrow is the electrical field of third charge. So if you want to find what is your x component, it's very easy. What is x component? You have two arrows in the x direction. So we can add this E2 and E3. Clear? How to find the x component? My x component of electrical field, which is equal to E2 plus E1. Sorry, E2 plus E3, right? E2 plus E3, right? E2 plus E3, both are in the x direction, and we already know the value of E2 and E3. What is the value of E2 and E3? The E2 is 1152 and this one is 720. 1152 plus 720, I got the answer as 1872. What's the value? 1872 Newton per coulomb. And what is your y component? It's very easy. From the diagram itself, you can easily find the answer. Am I right? It is in the negative direction. Am I right? So negative value of E1. So E1 we got 144. So my y component value is minus of 144 because this field is in the negative direction. So negative of y-axis, right? So how I can write? I can write this as 144, but takes negative value because it is in the downward direction. Clear. Now you can easily find the magnitude. Actually, they did not mention these things in the question. They just only ask you to calculate the electric field. But better, we can find what is its magnitude, what is its direction. That will be easy for our understandable purpose. Clear. So magnitude. How to find the magnitude? Magnitude is equal to square root of E of x square plus E of y square. So square root of E of x is 1872 square plus EY is negative of 144 square. What's the answer? Square root of 1872 square plus 144 minus negative of 144 square. I got 1877.5. Better I can round the value. 1877.5 I got. So I can rounded this to 1878 Newton per coulomb, right? Now you can easily find what is its direction also. So theta equal to tan inverse of y over x. What is your y? Y is minus 144 and your x value is 1872. Tan inverse of minus 144 over 1872. We got the answer as minus 4.398. So I can write these as minus 4.4 degree. So it exactly says this is in fourth quadrant. Am I right? You have to see the figure. This is our figure. Am I right? So if you see, if you extend this side x-axis and y-axis, so your answer lies in fourth quadrant. Clear? So this angle exactly in fourth quadrant. So if you want to give the answer in terms of 360, just subtract the value 360 minus this value, you will get the answer. Clear? Clear? 360 minus 4.4 gives you maybe closer to 355.7 something will get. Clear? Okay, this is the answer. Now we have to move to the sixth question. Actually, the sixth question has two subdivision. So we just do one by one, and few more question is I think we have only 9 question in this tutorial. I think this is our sixth question. Okay, read the question. Determine the electric field strength at point 1 centimeter to the left of the middle charge. So what is the middle charge? You have to see this figure. Q1, Q2, Q3 are exactly sitting on a line, and here Q2 is the middle charge. So what they say is exactly 1 centimeter to the left of middle charge. So that means we take this over 1 centimeter approximately. So in this place it's 1 centimeter. So the distance between this point and the charge Q2 is 1 centimeter. Clear? Clear? Okay. So we are going to find what should be the electrical field at this point based on all these three charges. So again, we have to play with the rule E, which is equal to K Q over R square. Clear? And the value is already mentioned. So we just work out with one by one. So first of all, I'm going to find what is the electrical field of charge Q1 at this point. We take this is our point P. Clear? Okay. So what is your E1? E1, which is equal to K, the magnitude of Q1 over R square. So what's the distance? If you know the distance between Q1 and Q2 is 3 centimeter, means what is this distance? This distance is 2, right? Am I right or not? This is your 2 centimeter. 2 multiplied by 10 power minus 2 the whole square. Clear? Because I have to convert it to meter. So now I'm going to substitute the value. 9 multiplied by 10 power plus 9 multiplied by magnitude of the first charge, so 6 microcoulomb. So 6 multiplied by 10 power minus 6 over 2 multiplied by 10 power minus 2 the whole square. Clear? Let's see what's the answer for the E1. 9 10 power 9 multiplied by 6 10 power minus 6 over 2 10 power minus 2 the whole square. I got 1.35, 1, 2, 3, 4, 5, 6, 7, 8. 1.35 multiplied by 10 power 8 Newton per coulomb. I have to find the same method for electrical field 2. K magnitude of Q2 over, what's the distance between Q2 and point P? It's 1 centimeter, right? One multiplied by 10 power minus 2 the whole square. So 9 multiplied by 10 power 9 multiplied by second charge is 1.5 microcoulomb. So 1.5 multiplied by 10 power minus 6 over 1 multiplied by 10 power minus 2 the whole square. So 9 10 power 9 multiplied by 1.5 10 power minus 6 over 1 10 power minus 2 the whole square. Again I got the same answer, right? 1.35 multiplied by 10 power 8 Newton per Coulomb. But you have to see which direction. Actually here, when you bring the positive charge from point P to this Q1, it will be repelled. So it will go to the positive direction of x-axis. Likewise, if you bring a test charge from point P to second charge, what will happen? It will repel to the negative direction. So better we can take the answer as negative, because here the repulsive force in the negative direction. Clear? Okay. Likewise, I have to find what should be the third value. So what should be the third value? E of 3. I can directly substitute the value. 9 multiplied by 10 power plus 9. And what's the value of the third charge? It's minus 2 microcoulomb. So I'm going to take only the magnitude. So 2 multiplied by 10 power minus 6 over, what's the distance between the third charge to this? Because the distance here already is 2. So 2 plus 1, 3, right? So 3 multiplied by 10 power minus 2 the whole square. Let's see what is the answer for this. 9 10 power 9 multiplied by 2 10 power minus 6 over 3 10 power minus 2 the whole square. So 2.0 multiplied by 10 power 7 Newton per Coulomb. Now how to find the net electrical field? That's a very, very important thing, because they said we are going to find what should be the net electrical field at this point P by these three charges. So how to find the net electrical field? The net electrical field is the combination of E1 plus E2 plus E3. And you have to see the first charge, the first electrical field is 1.35 10 power plus 8, and the second one is minus 1.35 10 power 8, and the third one is 2.0 multiplied by 10 power plus 7. You can see we can cancel these two. So what is the net electrical field at this point P? The answer for the first question, the net electrical field at the point P is just 2 multiplied by 10 power 7 Newton per Coulomb. So at this point, what is the electrical field? At this point, the electrical field is 2 multiplied by 10 power 7. Clear? Understand? Okay. Now we have second part. What they mentioned in the second question, I will expand this. What they will mention in the second question, because in this point we already found the value of the net electrical field. In this point, what is the electrical field? We found the answer in the first part, which is 2 multiplied by 10 power 7 Newton per Coulomb, right? What they mentioned, if a charge of minus 2 microcoulomb is placed at this point, what are the magnitude and the direction? So we are going to find what should be the magnitude and the direction of the forces. So you have to give the magnitude of the force, you have to give the direction of the force. So if you bring the charge minus 2 microcoulomb here, what will happen? This is a negative, and we already have the electrical field. As we already studied the rule, what is the rule? F, which is equal to Q multiplied by the electrical field. So electrical field just before we found in the previous part. But what is the charge? We are bringing minus 2 microcoulomb in this place. So minus 2 multiplied by 10 power minus 6 multiplied by the electrical field at this point we found in the first part as 2 multiplied by 10 power 7, and when you multiply, what will happen? That will be your answer. Multiply by minus 2 10 power minus 6, we got minus 40 Newton. So what's the answer? The magnitude of the force is 40 Newton, right? And what is the direction? It has negative value, so that means the force is exactly to the, what's the direction? The direction is to the left, am I right? Because we got the negative value. So what's the direction? It is moving to the left. Clear? Clear? That's it. Now, I think this is our last question. And then after that, we have the fill in the blanks as well as the match the following. That is very easy. And this question also very easy. So we have to read the question. Here there is no value, but we have some rules we already studied in the theory, right? What is given in the question? The figure below shows the electrical field lines for 2 point charges separated by a small distance. So you have to see the figure. We have point charges Q2 and Q1, and we are going to find what is the ratio of Q1 over Q2. There is no value, am I right? How to find? In the theory we studied, am I right? What we studied in the theory? The number of electric field lines leaving or entering the charge is proportional to the magnitude of the electric charge. Am I right? So now we have to see how many charges are entering this Q1. We have to count the number of lines, electrical field lines. 1, 2, 3, 4, 5, 6, 7, 8 lines are entering for Q1. Am I right? So for Q1, how many electrical field lines are 8? For Q2, how many electrical field lines are coming out? How many electrical field lines are coming out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrical field lines coming out of charge Q2, right? Am I right? So we can find the ratio in this way because we already studied these things in the theory. The number of electrical field lines leaving or entering a charge is proportional to the magnitude of the electrical charge. So Q1 over Q2 is equal to the Q1. How many lines are entering? The number of lines entering is 8. The number of lines are coming out of Q2 is 16. That will be your answer, which is exactly 0.5. Clear? Clear? That's it. Okay, now we have to answer the fill in the blanks. So what is given here? The electric force acting between two charged particles is dash to the product of magnitudes of the two charges and dash to the square of the separation between them. Actually, they are talking about the Coulomb's law. What is that? Electric force F, which is equal to K magnitude of Q1 magnitude of Q2 over R square, right? So what they mentioned the first part, the electric force acting between the two charges is dash to the product of the magnitude of two charges. So that means it is directly to the product of two charges. So that means the answer here is directly, clear, to the product of magnitude of two charges and dash to the square of separation between them. So what is the directly? Here it is indirectly, am I right? Whenever the distance will be more, the electrostatic force will be less. So here it is inversely. Clear? And second question, similar charges dash each other and different charges dash each other. We studied similar charges always repel each other and different charges always attract each other. Clear? And third question, the number of electrical field lines leaving or entering a charge is proportional to the magnitude of the, just before we work out the question, what we did here? What we did here? We found the value of Q1 and Q2 by the number of electrical field lines. Am I right? That means the number of field lines leaving or entering a charge is proportional to the magnitude of the electrical charge. Am I right? So the answer here is electric charge. Clear? That's it. Now we have to match the following. Coulomb's constant. Coulomb's constant is not Coulomb. Coulomb constant is not electric force between the pair of charges. Coulomb constant is not F over Q, but Coulomb constant unit is this one, right? Okay. Electric charge, the unit for electric charge is Coulomb. Coulomb's law. Coulomb's law is applicable for the electric force between the pair of charges, right? So this is the answer. And finally, electrical field, the unit for electric, what's the rule? F, which is E, which is equal to F over Q is the rule for the electrical field. So the answer for the last question is F over Q. Force per charge is nothing but electric field. Clear? That is okay. That's it. Thank you.